let y1 comma y2 comma y3 dash and y3 double dash. So in the previous problem we have taken y1 and y2 dash and y2 double dash because it happened in the second equation, but here it happens in the third equation. It happens in the third equation. So that's why what I will take y1 for this, y2 for this, whereas y3 dash and y3 double dash for both the equations. So be the associated non-negative dual variables. Right? Then the dual problem is, then the dual problem is what? It is to be minimized, then the dual has to be maximized. Max z dash is equal to max z dash is equal to minus 3y1. So why it is minus 3y1? Because minus 3y1 plus 5y2 plus what? It is 2y3 dash minus 2y3 double dash. Fine. So subjected to subjected to 2y1 plus y2 minus y3 dash plus y3 double dash. Fine. What it is? Less than or equal to 0. So it is 2y1, it is minus 2y1, here it is minus 2y1 plus y2 minus y3 then plus y3. So it is y3 minus y3 dash, here it is minus y3 dash plus y3 double dash. Fine. And where it's subjected to 0, it is here, it is 0. Fine. So the next one is what it is? Minus y1 plus 2y2. This is minus y1, this one, then 2y2, then what? It is plus y3 dash, then it is minus y3 double dash and taking greater than equal to, sorry, less than equal to 1. So the next one is, it is 0y1, let me write here as it is 0y1 because there is no x3 term here, but 6y2 plus 2y3 dash minus 2y3 double dash, then followed by greater than or equal to, sorry, less than or equal to 3. Fine. Continuing here only, whereas y1 comma y2 comma y3 dash comma y3 double dash are greater than or equal to 0. here substituting, what you are supposed to substituting y3 dash minus y3 double dash is equal to y3. Then max z is equal to minus 3 y1 plus 5 y2 minus y3, sorry, minus, how much it is, 2 y3. Subjected to constraints. Is that it is minus 2 y1 plus y2 minus y3 is less than or equal to 0. Fine. So I have written like this. Whereas minus y1 plus 2y2, then it is plus y3. Is it plus y3? Yes, plus y3 greater than or equal to 1. Whereas 6y2 plus 2y3 is less than or equal to 3. Fine. And y1 comma y2 comma y3 are greater than or equal to 0. And this is what? Given. And actually this is a prime. What happens here? Initially when the problem is given, the LPP is not in the canonical form. So we need to first convert the given LPP into a canonical form, then try to find the given of it. Fine. So why this given LPP is not in canonical form? The question arises here. The reason is that the objective function is to be minimized, then the respective constraints should be of greater than or equal to type. In the same way, if the objective function is to be maximized, then the constraints should be of less than or equal to type. But here in this case, the constraints are what? One constraint, that is, one constraint is less than or equal to type, whereas the third constraint is equal to type. That's why the given LPP is not in canonical form. Fine. Now we have to convert this LPP, which is not in canonical form, into canonical form with respect to these two, what? These two equations. Because of these two equations, the given LPP is not in canonical form. So how to make this LPP into canonical form? Fine. So as the given LPP is of minimization, all the constraints are supposed to be greater than or equal to type, but these two equations are not in that type. So we need to convert these two equations to the greater than or equal to type. Fine. So to do that, what we do here, we take this first equation. We take the first equation, that is 2x1 plus x2 is less than or equal to 3. The continuation of this will be explained in the next. Right?